Le damos continuidad a esta primera jornada nacional e internacional de ayudantes para herbicidas, contando quiénes van a ser los próximos disertantes, Luis, para que la audiencia sepa a quiénes va a escuchar dentro de un ratito nomás.
Bueno, el próximo disertante es un disertante internacional, es el doctor Bryan, va a estar en la próxima exposición, después va a estar seguido por la licenciada Ana Gaiotto de Industrias Ebony en Brasil, Santiago Oldani de Trotfen y el ingeniero Eduardo Astini de Nexagro.
Y luego de ellos también vamos a escuchar al ingeniero Eduardo Cortés, al doctor Ignacio de la Ferrera, una conferencia que vos ayer te permitiste hacer un comentario recomendándola, ¿no? Porque
desde luego,
se trata de un trabajo...
Es decir, han desarrollado un trabajo en laboratorio desprofeso para esta jornada. O sea, estuvieron evaluando ayudantes para el control de quinocloa y de yuyo colorado.
Y después de ellos lo vamos a tener al ingeniero agrónomo Gustavo González Anta y al ingeniero Julián Oliva, a quien conocemos, ¿no es cierto?
Por supuesto.
Quien debe además, dentro de un instante, hacerse cargo de la presentación de las presentaciones de las próximas conferencias junto con Lucas Remondindo, ambos miembros de una de las entidades organizadoras de esta jornada, esto es AX Consulting.
Efectivamente.
Estamos sembrando la agricultura que vos y el mundo necesitan para que los cultivos se transformen en más y mejores alimentos. Desarrollamos tecnologías microbiológicas que estimulan el crecimiento y así podemos nutrir al campo y al mundo pensando en hoy y en el mañana. Rizobacter, mejor agricultura.
El mundo no solo necesita alimentos, necesita el campo en su mejor versión. Y ya. Sabemos que una cadena es tan fuerte como su eslabón más débil, y la aplicación de fitosanitarios hoy es el eslabón de porcelana en la cadena de valor del campo. El paso adelante está en implementar a escala global las soluciones que ya tenemos disponibles. El paso adelante es nunca dejar de cuestionarse y entender que el cambio no es un fin, sino un proceso constante e infinito de mejora. Por eso en Speed Agro, además de ser especialistas en coadyuvantes, generamos protocolos de aplicación, llevando la eficiencia más allá del laboratorio, transformando la información en conocimiento. Ofrecerle al mundo la mejor versión del campo no se trata de avanzar a pasos agigantados, sino de preguntarte, ¿qué paso adelante diste hoy? Speed Agro, The Greener Standard.
Hoja por hoja, Ligier llega a donde tiene que llegar. Desde hace 20 años, somos expertos en elaborar coadyuvantes que mejoran tu experiencia en aplicaciones. Coadyuvantes Ligier, respaldando la misión de cada gota.
Bueno, Lucas, ¿cómo estás?
Buen día.
empezando esta segunda parte de la mañana y de la segunda parte de la jornada. Excelentes conferencias las que hemos escuchado hasta ahora.
Sí, lo tuvimos a Papa primero, al ingeniero Papa, muy interesante con la parte de pH, correctores y calidad de agua.
Sí, lo de Mariano Luna, impresionante los datos que brindó en su conferencia.
Así es, y ahora vamos entrando de lleno hacia el centro de la jornada, y es un espacio auspiciado por Spidagro.
Una parte internacional, se podría decir.
Sí, señor, este es el primer expositor internacional del día, y es el doctor Bryan Young, que es profesor asociado de la Universidad de Purdue del centro de Estados Unidos.
Su conferencia, uso de adyuvantes en función de las condiciones ambientales.
El mundo no solo necesita alimentos, necesita el campo en su mejor versión. Y ya. Sabemos que una cadena es tan fuerte como su eslabón más débil, y la aplicación de fitosanitarios hoy es el eslabón de porcelana en la cadena de valor del campo. El paso adelante está en implementar a escala global las soluciones que ya tenemos disponibles. El paso adelante es nunca dejar de cuestionarse y entender que el cambio no es un fin, sino un proceso constante e infinito de mejora. Por eso en Spidagro, además de ser especialistas en coadyuvantes, generamos protocolos de aplicación, llevando la eficiencia más allá del laboratorio, transformando la información en conocimiento. Ofrecerle al mundo la mejor versión del campo no se trata de avanzar a pasos agigantados, sino de preguntarte, ¿qué paso adelante diste hoy? Spidagro, the greener standard.
Greetings. Hola. I'm Bryan Young, a faculty member at Purdue University. I'm a weed scientist by training and have been doing so for the last 30 years in my professional career. And I appreciate the invitation to talk to you today about the use of herbicide adjuvants based on environmental conditions. So thank you to the organizing committee to participate through this virtual presentation today. So the first thing I need to do is classify adjuvants, because maybe how they're classified in Argentina, South America might be different than how we do that in the United States. So just from my context of how I classify adjuvants, we have different spray modifiers. Spreaders, stickers, drift control agents, activator adjuvants, such as the oils and surfactants, nitrogen fertilizers, utility modifiers, and then we can classify adjuvants by their chemistry as well. For today's presentation, though, I'm going to be focusing on the activator adjuvants because we're talking about how to make adjuvants work under different environmental conditions. And I'm assuming that we're not talking about spray drift. That's been a discussion point, obviously, here in the US with dicamba issues and then concerns about 2,4-D. But I want to talk more about the environmental conditions where these activator adjuvants get us more activity out of the herbicide to help kill some weeds. So first off, what do these activator adjuvants do? Here's the leaf surface, a cross-section of that leaf surface, and they help associate these spray droplets of that herbicide solution with the leaf surface. They improve that contact and improve absorption into that first barrier, the epicuticular wax, the cuticle layer. And they might improve the solubility of the herbicide moving through some of those barriers, such as the cuticle. And they can also aid in some cases with transport of the herbicide through that, through the plant. And that's where ammonium sulfate, ammonium type fertilizers have been documented to improve movement once inside the plant. But of course, in terms of how we use adjuvants, which one should you be using, comes down to what's allowed on the pesticide label, what's recommended on that pesticide label. So here are the most common ones that are cited here in the United States, all the way from non-surfactants to some of the utility modifiers that we use for some herbicide combinations. In general, surfactants are surface active agents, and they improve the association of that spray solution with the target surface. In many cases, in a foliar application, that would be, of course, the leaf surface. So you can see on the left, these pictures are showing spray droplet without a surfactant on the right, with a surfactant, the top view, side view, and it just increases the surface area of that spray solution contacting the leaf. Now, we also describe surfactants as making water wetter. So hopefully it will improve the movement of that spray solution into the leaf as well. There are some surfactants that are good at penetration into even somewhat oily substances. There are others that do just what I described, making water wetter, reducing that surface tension. There are a lot of surfactants in even the brand herbicide formulations that we use in the jug, if you will, but the tank side adjuvants help out with reducing that surface tension even more to create better contact and better movement into the leaf. You can see here's a spray droplet applied, stuck up on a leaf hair, or what we call a trichome. Absorption of the herbicide is not going to occur through the trichome. It needs to get down here at the base of the trichome or leaf hair to have absorption in the leaf occur. So this is a problem when no surfactant is involved. Compared to when a surfactant is used, you couldn't even see the droplet hit the trichomes because it immediately moved down the trichomes and made good contact with that leaf surface for absorption to occur. Again, these trichomes are more of a barrier for herbicide uptake than they are a conduit of uptake occurring. So we have spreading of that herbicide solution on the leaf, creating more of a contact interface for absorption to occur. Now, what we need to be mindful of, though, is there are some surfactants that are sold as super spreaders. So creating a thin film of the herbicide solution on the surface, and that can be concerning because the more of a thin film that you create, the thinner that is, the faster it's going to dry. And herbicides are only going to be taken into the leaf in an aqueous form, in the water phase, if you will. So the faster it dries, the shorter time for herbicide uptake to occur. Now, surface spreading in a thin layer might be fine for fungicides and some insecticides, but for herbicides, they all need to move into living cells. They need to move through that cuticle. And so super spreading is not a goal that I have personally for maximizing herbicide uptake. So let's look more into this. So the leaf surface, starting with the epicuticular wax, is a gradient of hydrophobic, oil-loving compounds moving towards the inside of the plant, towards the cells, where it becomes more hydrophilic in nature. So hydrophobic, oil-loving, moving towards hydrophilic, water-loving. And within there, you have all sorts of different compounds, ketones and cutin, wax, carbohydrates that vary in the amount of hydrophilicity or water loving that they have. So how does herbicide enter the leaf? Simple answer would be the path of least resistance, because it's happening by diffusion. So if you are a hydrophilic herbicide, a water-soluble herbicide, you'd probably find a polar route. So through this matrix of the cuticle, you would go anywhere that likes water. And so you're going to find that path. If you're an oily herbicide, you'd find the nonpolar path. So you'd stick to more waxes and maybe more of the cutin relative to some of the pectin. So we have the hydrophilic path and the hydrophobic path. These are going to be important paths as we talk about how the environment can influence your paths of entry as well. So for non-nitrate surfactants, the way we describe them in the US and the way we use them in the US is they're applied typically at 1/4 to 0.5% volume to volume. I know that can be lower concentrations, especially in South America. And we're applying these in carrier volumes anywhere from 94 to about 180 liters per hectare of spray carrier. They do make water wetter, reduce the surface tension. That's the primary job. They can help movement through the cuticle, especially in those hydrophilic pathways that I just described. So surfactants can help movement of herbicides if they're moving along that hydrophilic path. They're not very aggressive in terms of membranes or cuticles, so less injurious to the crop or desired plants. And in some cases, the surfactant may be all that's necessary to optimize a herbicide's activity. The auxin herbicides, such as dicamba and 2,4-D, would fit in this category. That surfactant, a good surfactant, is really all you need to optimize herbicide activity. Then we move to the oil-based adjuvants, and they serve several functions: enhancing the wetting and spreading, increase movement through the waxy cuticle, reduce evaporation during flight to the target or on the leaf surface itself in that spray deposit. Because we have concerns about small droplets moving through the air to the target under arid, high temperature conditions, evaporating before they actually hit the target. Oils will help reduce that evaporation so that they do ultimately hit that target. We have two types of oils used: crop oil concentrates, modified seed oils. Really the same purpose, just the modified seed oil is a little bit more aggressive at penetrating through the cuticle. There are a lot of oil-soluble herbicides that we use these with, such as ALS herbicides, triazines, ACCH inhibitors, the group 1 herbicides, group 27 herbicides, and group 14 herbicides. Typically can be optimized with oily adjuvants. And then ammonium fertilizers. The last group of activator adjuvants that I'll talk about. Basically, we're using something such as urea ammonium nitrate or ammonium sulfate. Ammonium sulfate probably being the most common one, and the use of glyphosate has made that an everyday type of application for herbicides. But they can help condition hard water. But what has also been shown to occur is there's evidence that the addition of AMS can improve the translocation of some herbicides. I can't think of any other adjuvant that does that, but I know in the case of AMS, ammonium sulfate, it has been shown to increase translocation of herbicides such as glyphosate. So how does the environment influence what adjuvant might be best? We might have rainy conditions, droughty conditions, cold conditions, hot conditions. Well, they can change the droplet physical properties. As I mentioned, under arid environments, the droplet may try to evaporate very quickly as it moves through the air or on the leaf surface, reducing the opportunity for uptake into the plant. Might also influence the leaf cuticle composition, the fluidity. So I think of the cuticle as a stick of butter, and the warmer it gets, the more fluid it becomes. The colder it gets, the more rigid it becomes. So under warmer conditions, the cuticle becomes more fluid and easier for penetration of something through it. And then also look at relative humidity as a way of looking at the hydration level of the cuticle, because the cuticle isn't just a solid plane of wax. There is air pockets associated with it. There are pores. And as you increase humidity in the air, you increase the amount of water that's going to associate with that cuticle. So essentially under higher humidity conditions, you have a little bit more hydrophilic cuticle layer. And so once again, let's look at these. Under high temperature, we have more fluid, less viscous composition of the cuticle as a whole, easier to penetrate. Higher relative humidity, greater hydration of the cuticle, more hydrophilic, easier to penetrate. Higher rainfall, good soil moisture compared to a drought. Cuticle formation will be a little bit more hydrophilic in nature because it's not trying to prevent water loss as much as a droughty condition. So let's go to the map of the United States for annual rainfall or precipitation. On the eastern half of the US, we have the rainier area, higher rainfall, higher precipitation, and the west, the more arid environment. In looking at the temperature, the cooler the further north we go, the cooler the temperatures. This is just annual average maximum temperature for these different regions. But here's the most important map I want to share as it relates to how we use adjuvants in the United States with herbicides. We have the Mid-South and Southeast, which we describe as hot and humid. Some would call it, well, some frankly call it hell, or hot as hell, humid as hell. It is very warm, very humid. Moving north to where I'm at here in Indiana, it's warm and humid as well. It's seasonal though, whether it's warmer, maybe in the summer it does get indeed hot. And then we move to the northern Great Plains, where it's a little bit cooler and a little bit more arid, a little bit less rainfall environment. And then out west, it can be cool or hot, depends on what elevation you have in reference to the Rocky Mountains. But typically, it's going to be arid, not a lot of rainfall in most parts of the Western US. We also have seasonal changes. So not just regional changes for environmental conditions, but also seasonal changes. If we look at the upper Corn Belt or the Corn Belt in general, we might start applying herbicides in April for burn down and start to have residual control. As you can see, that by the yellow is relatively cool compared to some other environments. Let's say if we apply a herbicide in April versus July. You can see we got a lot warmer in July in the same states where we're cooler in April. So our adjuvant recommendations will vary, depends on the season. We'll probably utilize more of the oil adjuvants in the burn down prior to planting season when it's cooler. And then progressively, we can probably move towards something that is less aggressive, like a non-nitrogen surfactant, as it gets warmer out, because the cuticle has become more fluid. So let's look at this region by region. So hot, humid conditions. My colleagues in weed science in the Mid-South and Southeast, they are really challenged to find the value of some adjuvants at times. Herbicides work. It's hot enough so you have more of a fluid, less viscous cuticle, easier to penetrate, and the higher humidity has more water associated with it. So it's more of a hydrophilic cuticle layer. So they might use surfactant, and that's all they see the need for is just surfactant, because it's very optimal for movement through that cuticle because of the hot and humid conditions. Now we move to what I'd like to call kind of the central Corn Belt, warm and humid. It could get hot, actually, and it has been hot during the summer months. Just depends on what season we're talking about. But typically, it's not going to be as hot as the Mid-South I just described, but it's warm. So the cuticle is more restrictive than being extremely hot. Yet with the humidity, it's probably hydrated. So there's a chance that you might see a benefit from oil adjuvants to help moving through that cuticle that's a little less hydrophilic because, might not have as much humidity involved, but certainly it's going to be less fluid because of the cooler temperatures. Then we move north where it might be a little bit drier and certainly a little bit cooler. So under those cooler conditions, you have a more restrictive cuticle layer. So it's less likely to get penetration through there. And it's a little bit more arid, meaning you have less hydration of that cuticle. And you have greater potential for those droplets that are sprayed from the spray tip going to the target to evaporate because more arid environment, just water is evaporating from it. And once on the leaf surface, they might reside there for a shorter period of time before they dry because of that drier air under less relative humidity. So under these conditions, we really see a benefit towards the use of oil-based adjuvants under cooler and more arid environments. Cooler is also where we get challenged in terms of getting enough herbicide translocation for systemic herbicides. And that's where the use of ammonium sulfate can also be beneficial because it's cooler Movement inside the plant won't be as good because you have less metabolic activity overall. So the addition of AMS may improve some of the systemic activity you get from even a herbicide like glyphosate. And then moving out west, where it could be cool, could be hot, depends on where you're at geographically and time of year, but certainly is arid. And because of those dry conditions, the cuticle is going to be fairly hydrophobic. It's trying to keep water inside that plant. And so that's where oil adjuvants help penetration. AMS can help with that penetration, absorption in the leaf. And also under those drier conditions, if translocation is limited, the AMS might help with translocation of the amount of herbicide that is absorbed. So let's apply this to Argentina. When I look at this map, now keep in mind, I've never applied a herbicide in Argentina. I've never done a herbicide adjuvant evaluation trial in Argentina. So I'm just guessing here. What I see is a major crop production region with temperate, no dry season, could be hot or warm. So this reminds me a little bit of our southern region of the US, where you're going to have higher humidity, possibly. So maybe you have somewhat hydrated cuticle, warmer temperatures, maybe it's a little bit more fluid. So I'm guessing that there might be benefit of some oil adjuvants here. It might depend on the seasonality of it because it is a temperate environment. So what time of year you're applying it. That you might have benefit to using some of these oil-based adjuvants and not be fine just with surfactant. I see other areas that are more arid. In those, certainly I would think an oil-based adjuvant, at least a component of an oil-based adjuvant in a product that you use would have even greater benefit than just a straight surfactant. These are my guess. So maybe it's accurate, or maybe you'll call me a liar. What I can help with, though, is a rule that has been proposed here in the US by North Dakota State University. They have used it. They don't promote it quite as much as they used to, but at North Dakota State University, where it typically is a little bit more arid and a little bit cooler, they have the 140 rule. So what is the 140 rule? The 140 rule is you add the temperature in degrees Fahrenheit and the relative humidity as a percentage. If the sum is above 140, NIS adjuvant may be sufficient, because that means if it's above 140, it's either warm enough that you have a more fluid cuticle, or the humidity is high enough that you have more of a hydrated cuticle, that maybe a surfactant is fine to allow for hydrophilic movement into the leaf by just using surfactant. If the sum is less than 140, that means you're either cool or more arid. And that's where oil-based adjuvants may prove to be more beneficial. So one example would be 85 degrees Fahrenheit, which translates roughly to about, 28 degrees, 29 degrees Celsius. Well, 30 degrees Celsius. I guess I have it right here, excuse me. But 85 degrees Fahrenheit plus 55% relative humidity equals 140. So if I do the conversion, 30 degrees Celsius plus 55% relative humidity is 85. So is there an 85 rule for South America? I don't know. It'd be interesting to see how that might work out. But typically, if we're above 85 degrees or 30 degrees Celsius, we feel it's warm enough that a surfactant might work. It depends on the humidity after that and the chemistry of the herbicides that you're applying. If you have chemistry that's really just an oily herbicide, it might be best if you apply that with an oil-based adjuvant then. The rule of thumb is for oily herbicides, oil-loving herbicides, typically performance is best with an oil-type adjuvant. So to summarize, higher temperatures, it might reduce the benefit of activator adjuvant, especially oil-based adjuvants, because you have a cuticle that's easier to penetrate. Think of it again like a stick of butter, not a stick of butter in your refrigerator, but as the temperature goes up, you left it on the kitchen counter. It's easy to spread on your on your bread because of it. That's kind of like the cuticle under warmer conditions. Easier for spray solutions to penetrate under higher temperatures. Oil-based adjuvants can improve that cuticle penetration, and AMS can improve absorption as well as translocation. And you might see a greater benefit under that, or for that, under cooler conditions where translocation might be more limiting. In terms of relative humidity, again, think of this as somewhat of a measure of how hydrophilic your cuticle might be. Typically think of the cuticle not being very hydrophilic at all, but there is water associated with it because there's air associated with it. So the higher humidity, the more hydrophilic opportunity you have to move through that cuticle. The lower the humidity, the more hydrophobic it becomes, the more difficult it is to move through there unless you really drive it through use of an oil-based adjuvant. Under arid environments, you might see a benefit of the oil-based adjuvants by reducing droplet evaporation, moving through the air during deposition process, or you might see that droplet evaporating quicker on the leaf surface. The longer it stays in the liquid form, the longer you have for uptake to occur into that leaf for the herbicide. Oils will reduce the evaporation of water and keep it in an aqueous form a little bit longer, so they have longer period for herbicide uptake to occur. We call that the dwell time. So we have different factors that are involved with herbicide efficacy. On the left, I'm listing some of those factors that are managed by the applicator: the herbicide solution, the sprayer, what's put into that sprayer, the spray parameters. On the right, those that are limited in our ability to manage, such as the weeds we have as targets or the environmental conditions. For this presentation, though, I'm just trying to highlight that we do have some environmental conditions that we can't control. But because we do know what the environmental conditions are, we can adjust something over here on the left, being the adjuvants, and hopefully design a more optimal application solution to make sure the herbicides perform well. So hopefully this was on target in terms of my presentation today to give you information about how environment influences adjuvant choice, how we approach that in the US, and maybe some things to consider for how you do it in South America and Argentina. So I thank you very much for your time. You choosing to view my presentation today. I hope you have a great conference. And again, thank you for the invitation to participate and the conference organizers. Have a great day. Thank you very much.